Hello, Geometry Geniuses. Mr. Stewart here. Today we are doing Unit 7, Lesson 3, Equations of Tangent Lines to Circles. So we've already talked about how to do the equation of a circle, where the center point would be HK, radius is R. We would use the opposite positive negative values for the center point as what we see in the equation. And we've also used point slope formula to write the equation of a line, where the y1 and the x1 are any point on the line. The m is our slope, just like y equals mx plus b, m is the slope. And then we have put those things together and we have our equation of a line. We also need to talk about what it means to be tangent and the point of tangency. So the point of tangency is the point where a line touches the circle, but the line only touches the circle at that point. So it intersects the circle only once. If it cuts through the circle, it's called something else. We will get to that in a different lesson. But a tangent line means touching once. What we're going to do today is practice writing the equation of a circle and write the equation of a tangent line to a circle. So we're going to put some of these things that we've done together. We're going to need opposite reciprocal slopes to write perpendicular lines and the point slope formula, and we'll need the equation of the circle, and it's going to be a great time. All right, so let's just review what we did in our previous lesson. A circle's equation is written as x squared plus 10x plus y squared plus 9 equals 0. What I would like you to do, please, is find the coordinates of the center of the circle and then find the radius of the circle. You'll have to use the process of completing the square in order to do this. So please pause the video, find the center and the radius, and then graph it, and then come back. So we're using the process of completing the square. There's nothing to do. There's no work to do with the y values, but we complete the square with the x's so that we can get our radius and our center point. Now we're going to graph that radius and center point. So negative 5, 0 is our center point. And then we're going to graph our circle. So make sure that's done. Then it says write the equations of two vertical lines that are tangent to the circle. Draw them on the graph. So vertical line means it's going to go straight up and down. That's what vertical means. And if it's tangent to the graph, that means it will only touch the graph at one point. So if they're going to be vertical, the lines that we're drawing will be on the left side and right side of our circle. The equation of a vertical line is always x equals. So this first one that just touches the circle once, as the equation that x equals negative 9. And on the other side, our vertical line that is tangent to the circle is at x equals negative 1. So those are the equations of two vertical lines that are tangent to the circle, and we drew them on the graph. Now take a moment, please, and write the equations of two horizontal lines that are tangent to the circle. So you'll have a horizontal line tangent to the circle at the top and a horizontal line tangent to the circle at the bottom. And write those two equations and go ahead and draw them on the graph. So one of the equations will be at y equals positive 4. The other one will be at y equals negative 4. Again, tangent means it just touches the circle once. So right above the circle, touching it once, at y is positive 4. And then again, on the other end, y is negative 4. Next thing we're going to be doing is to determine whether a point is or is not on the graph. So what we do is just simply substitute in our numbers, x negative 2, y is 1, plug those numbers into our equation and see if the equation will check. So take a minute, plug the numbers into the equation at the top of the page. Negative 2 goes in for x, 1 goes in for y. Plug it into your calculator or mental math and see if they are equal. See if it checks. When we plug in the values, does it indeed check? And the answer is no, it does not check. So the point negative 2, 1 is not on the graph. And if you look on the graph, negative 2, 1 is inside the circle, not on the circle. Inside the circle does not count. It has to be on the circle itself. Okay, so next, draw a radius from the center to the point negative 1, 0. I have my radius drawn already. You need to draw yours in. You're drawing a radius from the center point to the circle. What is the relationship between that radius line and the tangent line that it intersects? So our tangent line is the equation x equals negative 1. Here's my radius. So if I take my radius and draw it horizontally from the center to the end of the circle, it is perpendicular to the tangent line that we drew earlier in this question. So the radius is horizontal, the tangent line is vertical. That means they are perpendicular or form a right angle. That is true about every radius and every tangent line. Every tangent line that is drawn to a circle will be perpendicular to the radius that goes to that point of tangency, which means you could do this, say the same thing about a diameter that goes to that point of tangency, because diameter is just doubling the radius length. So the tangent line will always be perpendicular to the radius at the point of tangency, which means the tangent line will also be perpendicular to the diameter drawn to the point of tangency. So tangent to a circle is a line in the same place that intersects the circle in one and only one point. A line in the same plane that intersects the circle at one and only one point. That point is called the point of tangency. So let's get into some practice. You got a circle at given as with the equation x minus 3 squared plus y plus 1 squared equals 25. Find the center and the radius and graph the circle. So please pause the video, state the center, state the radius, graph the circle. Now, the next thing we're asked to do is show algebraically that the point 6,3 is indeed on the circle. So you're going to plug 6 in for x, plug the 3 in for the y, and show that it checks to prove that that point is on the circle. Using the graph to prove a point is not on a circle is not going to work, because circle is not the same thing as a straight line with a slope. Circle, we'd kind of have to hand sketch and try to make it as round as best we can. A compass, using a compass on a circle is not exact as well, because the grid might not be perfect squares. They could be rectangles, in which case the compass is not going to show you exactly the correct points where the circle lands. So that's why we have to use algebra. Algebra is our fail-safe to know for sure whether the point is on the circle or not on the circle. And if it checks, that means yes, it's on the circle. So next, we want to draw the radius from the center to 0.63. So I plot 0.63. It is indeed on the circle, and I know that because I have the algebra to prove it. Then I'm going to connect the center of the circle to that point. What's the slope of our radius? Well, we can just count on the graph. It's up 1, 2, 3, 4, up 4 over 3. So our slope is up 4 over 3. That means we could write the equation of the radius using that slope and then the center point, or we could use that slope and the point on the circle. But the question asks us to write the equation of the tangent line at 0.63, not the radius. So what we talked about on the previous page is that the tangent line is perpendicular to the radius. So we'll use our perpendicular slopes. Since the tangent to the circle is perpendicular to the radius, we'll use the opposite reciprocal slopes. If the original slope was 4/3, then our perpendicular slope is negative 3/4, and our line will be passing through the point 6,3. So write the equation. And there we go. Now it says, write the equation of the tangent line to the circle that passes through the point 7, -4. What we need to do is figure out the slope of the radius that goes from the center point to the point 7, -4. Once we have that slope, we're going to use the perpendicular slope because our tangent line will be perpendicular to the radius. So then once we have that information, use point slope form and write the equation. Not a big deal. Okay, well, not a big deal so far. But here's when things get a little tougher. Let's consider the equation x minus 3 squared plus y minus 5 squared equals 20. Find the equations of two tangent lines to the circle that each have a slope of -1/2. So our tangent lines will have a slope of -1/2. Tangent lines have the slope of -1/2. Okay, so our center point for our circle is 3, 5, and our radius is radical 20. Now that's not convenient. We've been using circles with a nice, neat whole number radius. We don't have that here. So let's figure this out. If the slope of the tangent line is -1/2, then what will the slope of the radius be that intersects that tangent line? So if I know the radius, if I know the tangent line slope is -1/2, what's the radius slope? We're going to use that slope to find points, to find the points of tangency. So here's the idea. We know where the center of the circle is. That's at 3, 5. What we need to do is try to figure out we can find some way to get the points on the circle. So we would have to do a radius slope of up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. But we don't know how many times we have to do that slope till we actually reach the circle. So here's a little trick. If we take the Pythagorean theorem, let me get a pen ready here. If we take the Pythagorean theorem, which is a squared plus b squared equals c squared. Remember what we did in the first lesson is we pretended that we were counting, well, we didn't pretend, we counted up our Pythagorean triple lengths to get to the correct distance. I'm doing a very bad job of explaining this. All right, so what we did in lesson 1 is we had a radius of 5. So we went up 4 over 3 to get a point on the circle where the hypotenuse would be 5, with a radius of 5. We used the idea of Pythagorean theorem and a 3, 4, 5 right triangle to get an accurate exact point on the graph. We don't have an exact Pythagorean triple here, but here's the thinking behind what I'm doing. If I know that the radical 20 is the c portion, a squared plus b squared equals radical 20 squared, then when I square the radical 20, I need to see if I can find two numbers that add to 20 that may also be perfect squares. So your list of perfect squares are 1, 4, 9, 16, 25, 36. And we're really probably not going to go up bigger than that because our picture would be too far off our screen. Can you find two perfect squares that would add up to equal 20? And the answer is yes. 4 plus 16. So that means this could work to help us find some points on the circle. So 16 came from 4 squared, and 4 came from 2 squared. So then if I work backwards with the Pythagorean theorem, knowing that my c value, or the hypotenuse, which happens to be our radius length, will be 20, When I square that 20, the radical goes away. Two perfect squares that add up to be 20 would be 16 and 4. Unsquare those perfect squares. So it's 4 squared plus 2 squared equals the radius length. That tells me that I can go, to get more points on my circle, I can go up 4 over 2 and get another point on my circle. Or up 2 over 4 and get another point on my circle. Or down 2 over 4, or down 4 over 2. And I can keep doing that pattern, up 4 over 2 the other way, over 4 up 2, and then over 4 down 2, and then over 2 down 4. And that helps me get a nice set of points that I can try to connect and make into a round circle. So that doesn't always work because you won't always be able to find two perfect squares that add up to be your radius squared value, but it is another strategy that we may be able to use if the numbers work out. Okay, so now that taken care of, back to the question. We are supposed to find the equations of two tangent lines to the circle that have the slope of -1/2. Our tangent lines are supposed to have a slope of -1/2. So if we know the slope of the tangent line, that means all I need is the point of tangency to write the equation, because to write an equation, we need a slope and a point. That's why it's called point slope form. So we have the slope already. Our tangent lines will have slope of -1/2. That means our radius slopes will be +2. So go to your graph and draw in a radius with a slope of +2. And let's see where that radius meets our circle. So we're going to graph the radius with a slope of +2 to find our potential points of tangency. So if my radius is a slope of +2 over 1, there's one possible point of tangency. And then continuing on down in the other direction, there's my other possible point of tangency. Now that we have our two possible points of tangency, how do we verify that these are actually on the circle? So in order to verify that these points are really on the circle and not just guessing, or maybe I made a mistake screwing up where my circle is located, what I would have to do is plug the coordinates of each of these points into the equation to show that they are indeed on the circle. So again, algebra is our friend. We're going to use algebra to show that the points are on the circle. Once we have those points, we can check them. And those points are indeed on the circle. And if they're on the circle, that means they are the correct distance away from the center of our circle, matches the radius length because I plugged it in and it checked. Now we know the points. We had the slopes to begin with. The tangent lines, both tangent lines will have a slope of -1/2. And we write one equation for each of the points that we found. So y minus 1 equals -1/2 x minus 1, and then y minus 9 equals -1/2 x minus 5. That's the equation of the two tangent lines that have a slope of -1/2 that are tangent to the given circle. Fun stuff, eh? Okay, let's do it again. Maybe this one will go a little smoother. Consider the circle x plus 3 squared plus y minus 5 squared equals 8. There are two tangent lines, two lines tangent to this circle that have a slope of -1. Find the equations of both lines. We know the slope of the tangent lines already. We just need to find the intersection points between the tangent lines and the circle. We know the center of our circle will be at -3, 5, and we know our radius is radical 8. So what we're going to try to do is work backwards through our Pythagorean theorem and see if we can come up with a way to count and find some accurate points on our circle. So a squared plus b squared equals radical 8 squared. So remember, our perfect squares are 1, 4, 9, 16, in order to add up to be 8, we don't need any numbers bigger than that. What perfect squares will add up to be 8? Well, it would be 4 and 4. So if I unsquare those perfect squares, then from my center point at -3, 5, I can go up 2 over 2, down 2 over 2, in all 4 directions. So it gives me 4 points, and I can do my best to try to make a round circle. And so since our tangent lines have a slope of -1, I'm going to use the graph to figure out the radius slope of +1, where that radius might intersect the graph. That way our tangent lines will be perpendicular to our radius. So if the tangent lines have a slope of -1, then the slope we need for the radius is +1. And since the radius and tangent lines are perpendicular, we are going to use what we did with our slopes to find potential points. 1, 7, -5, 3. Sorry, -1, 7, and then -5, 3. Those are our potential points. We need to verify that those points are indeed on our circle by plugging those points into the circle equation. Either go to your calculator or mental math, and you can show that they check. So the other potential point was -5, 3. I'm going to plug those numbers into the equation, do the math work to show that the points are indeed on the line. So now that I know that those points are on the line, I'll use the point and the perpendicular slope to write the equation. And there's our 2 equations of our 2 tangent lines. So now you're just going to go practice, do this a couple times on your own. Use the answer key as you need it because it is there in Teams. And then after this lesson, tomorrow you have a quiz on forms. Okay, so make sure you're good to go. The quiz will open up soon, and let me know if you have any questions. Please take care of each other, and I'll talk to you soon. Bye.